Myself, Katam Ashok. Welcome to the Smart System Design lecture. What is smart system? Smart systems incorporate the functions of sensing, actuation, and controlling in order to describe and analyze the situation and to make the decision based on the available data in predictive or adaptive manner, thereby perform the smart actions. We'll see some of the applications of the smart systems. These are the some are the applications of the smart systems. Next, what are the components of smart system? First one is the sensors, second one is the processor or controllers, and third one is the actuators, and fourth one is the plant or environment. What is the black diagram of the smart system? First, plant. Use the sensor and sense the data from the plant and send to the signal conditioning. Will convert to analog or digital converter. In case data is digital, we convert to analog. And next connected to the microcontroller. And we take the data from the user interface and we'll convert to the analog or digital converter. Again, we'll send the data to the what are the required data to the drive controllers and actuators. See the one example of air conditioner. The room temperature measured by the temperature sensor, that is the 30 degrees centigrade, and it is sent to the microcontroller with help of analog or digital converter. And the user interface is connected to the controller. The user requires the 18 degrees Celsius. So again, we send the data to the driver circuit with help of analog and digital converters. The drivers have sent the data to the actuators. So next process, the room temperature will be decreased to 18 degrees Celsius. What is a sensor? Sensor is a device that measures the physical quantity and convert it to the electrical signal. For example, physical quantity is measured by a sensor and converted to the electrical signal. So we'll see some of the examples: temperature sensors, displacement sensor, position sensors, motion sensor, and velocity sensors, and fluid sensors, liquid flow, liquid level sensors. And we'll see other types of sensors is lightweight sensors. These are temperature sensors, and these are the water sensors and proximity sensors, gyroscopic sensors, and light sensors. And the gas sensors. These are color sensor, heart rate sensor, pAR sensor, vibration sensor, and joystick sensors, touch sensor, sound sensor, and so on. What is actuator? What is actuator? So, an actuator is a component of a machine that drives the mechanism of system. Mechanical actuators. First one is the gates, belt drives, chain drives, and the bearings. So, electrical actuators. What are the electrical actuators? Push button switches, which means push buttons and switches, relays, solid state switches, diodes, and transistor resistors on solenoids. Drive drive systems, AC or DC stepper motors. We'll see the microprocessor and microcontroller. Microprocessor. This is arithmetic logic unit on registers and control unit. Coming to the microcontrollers, CPU, RAM, ROM, input or output ports, timer, serial COM ports, and this is one of the microcontroller. What is Arduino IDE? It is open source electronic platform based on easy to use hardware and software for IoT applications. The most popular IoT devices developed in this platform only. It allows a low cost and easy way to create devices that interact with another environment So Arduino is an open source electronic platform to use easy to use hardware and software. Several boards and softwares. So first we'll see the boards. Arduino Mega 2560. This one is the Arduino Uno. So we'll see the Arduino Uno board description. This one is the Arduino Uno board. So first this one is a microcontroller that name is 8 Mega 328. This one is a USB port which is connected to the laptops and desktops with help of D to B cable, and is a Arduino power jack or adapter. We can give the DC or AC power supply with help of this jack. And coming to this a battery V in and ground, we can count battery connected to V in and ground. And this is LED power, which what is the use of this one means we give the external power to the board, so the microcontroller on, the LED turn on. So next one, this is the from 0 to 13 pins. This is a digital input and output pins. So this is from A0 to A15, total 6 pins used as an unlock input or output pins. So from this digital input or output pins, totally 14. In that 14, we have used 3, 5, 6, 9, 10 and 11 as a PWM pins. PWM means pulse width modulus. So this is a reset for the microcontroller. So this is a serial input or output pins. So this one is the I2C communication, SDA, SCL. And next 13, 12, 10, 11 as the SPI pins. So this one is the I2SP loaders. So coming to Arduino Uno technical specifications. Arduino Uno used as a microcontroller as 8 Mega 328. So clock speed of Arduino Uno is 13 MHz. So operating voltage is 5 volts. So input voltage, the limits from lower limit, upper limit. Lower limit is 6 and upper limit is 20. But the input voltage recommended is the lower limit is 7 and upper limit is 12. So digital input or output pins are 14. Out of 14 pins, we are 6 pins as a PWM pins. So PWM is pulse width modulus. So in this one is. So unlike input pins are 6. So DC current per input or output pin is 40 MHz. DC current for 3.3 volts pin is 50 amps, milliamps. So we'll see the pin description of the Arduino Uno. First pin category, pin number, and what is the use of that pin. First category is power pins. The power pins are V in, so 3.3 volts, 5 volts and ground. So what is the use of V in pin? Will give the input voltage of Arduino when using as a external power source. So what is the use of 5 volts pin? The power source, 3.3 power source pins, and ground pin is a ground pin. So next pin category is reset. So pin number is reset. What is the use of pin? Reset means reset the microcontroller. Next pin category, unlock pins. Those. Next category is AREF, unlock reference. What is the use of this pin? To provide the reference voltage for the input voltage. So next pin category is serial communication. In that pins we have two pins. One is RX and TX. RX means receiver and TX is transmission the data. To use receive and transmit the TTL. Next category SPI. So pin numbers are 10, 11, 12 and 30. What is the use of the additions? Next coming to Arduino programming. A program for Arduino is so in the sketch part there are two required functions in the Arduino sketch. Those are first one is void setup and second one is the while loop. What is void setup? A function run as once at start of time performs as a initialization. What is the while loop? A function called repeatedly until the boot power off. So other function must be created outside of the brackets of the functions. Because this is void setup and this one is a while loop. So basic Arduino functions. There are four basic Arduino functions, sir. First one digital input or output function. Second one is analog input or output functions, timer functions and serial input or output functions. From digital input or function basically in that category four types: pin mode, digital read and digital write. Unlike input output functions, in that there are two types: unlock read and unlock write. So timer function in that also two category: delay and delay microseconds. In coming to serial IO functions, first one is a serial begin dot, serial dot bin. First coming to the category of digital input or output functions. So in that first pin mode configures the specific pin to behave either as a input or a output. So first is a syntax. What is the syntax? Pin mode, pin. What is pin? Pin number and mode. We'll see what is the pin number. Any digital input or output pins from 0 to 13. What is the mode? Input or output mode. For example, pin number, I will write pin mode, pin number 13 output, which means pin number 13 behaves as a output. We'll see the another example. So pin mode, pin number 10 as input. So which means coming to digital input or function, next category digital write. So write high or a low value to digital pin. So syntax digital write pin number mode. Pin numbers from 0 to 13. Mode high or low. High means 1, low means 0. So digital write pin number 13 high, which means at pin number 13 the value is 1, which means we can know that 5 volts is there. Next example, digital write pin number 13 and low, which means 0 volts. Next, digital read. Read the value from any digital input pin. So syntax is int x, x as an integer, digital read pin number. From this, so pin number we can write from 0 to 13. For example, int x, digital read pin number 10, which means the Arduino read the data from the pin number 10 and stored in the x value. So x value is 0 or 1. Next, basic input and output interfacing. So we know that. So first one is Arduino, LED, resistor and switch. So this is the LED, light emitting divide. Resistors, these are the resistors, and push buttons. Working with Arduino Uno. First, connect the Arduino Uno to the PC with help of USB cable. I'm going to in the environment of IDE. Next, connect to the Arduino Uno to the PC USB cable Mega 2560. For that one is the Uno. For this one Mega 25. So controlling of LED using Arduino. So next, controlling of LED using switch. So, I'm taken one Arduino Uno. So from Uno I'm taken pin number 7 is connected to the push button. So under resistor I'm taken resistor is connected to the one end of resistor is connected to the push button, other end of resistor connected to the switch. This is switch, so I'm not press, so it is off, which means from push button to pin number 7 0 volts is coming. So Arduino understand from push button to 7. So at 7 there is no volts, only 0 volts. So Arnold told to the pin number 8. So from pin number 7 no data is coming. So please off the LED. So it is off. So next it is press. So from push button to pin number 7 5 volts is coming. So 5 volts is coming. So Arnold the another functions of Arduino is unlock input or output functions. In that, unlock read the data value from the specific unlock pin. So this why we'll see the syntax first. Syntax int x unlock read pin number. So integer. The x is a integer. So unlock read pin number. We'll see the example. So that from pin number from 0 to 13 we know that unlock pins from A0 to A15. Okay. So this is Arduino. I'm taken one unlock sensor is connected to A0 pin. Okay, we'll see. From unlock sensor 0 volts coming, which means in Arduino 0 value. From unlock sensor 0.004 is coming, which means in unlock value 1. Like that 0.0096 volt is coming. So value is 2. So 0.0146 volts is coming. So the value is 3. So 0.0915 volts is coming. The value is 4. Like that. The value at unlock sensor, from unlock sensor, the value 4.9951 volts is coming, which means in the sensor, in the Arduino, the value is 1023. At 5 volts is coming. The value is 1000. So the sensor, the output sensor is connected to pin number 3 of Arduino board. So from 0 value is given in the output. So the value is 0 volts. So next I am given the 1. So value 0.019 volts. So next is I am given 2. The value is 0.039 volts. So like that the value is up to I given 254, which means 5 volts. 255 with 254 means 4 volts. 255 means 5 volts. So next function is that timer function. So in the timer function, first one is delay. Pass the program for the amount of time in milliseconds for specific parameters. Syntax, delay, microseconds. For example, delay 1000, which means I am pass the program for 1 second. So 1000 milliseconds equals to 1 second. Next parameters, milliseconds, the number of milliseconds to be passed. So next is delay microseconds. Pass the program for the amount of time in microsecond to specify times. Syntax, delay microseconds. Bracket lo numbers parameter. The number of microsecond to be passed. Next, another function is serial input or output functions. These are 4 functions of Arduino basic functions. So in that serial input output function, first one is serial begin. Serial dot begin. This set the data rate in bits per second. This is called as band. Bits per second band for the serial data transmission. Serial dot begin in the speed. So for example, parameter speed in bits per second band. So next is serial dot print. So prints the data in serial port as a human readable ASCII text. So syntax is serial dot print the value. So parameters value, the value to be print any data type. Right. So next function is serial dot println. Println means new lines. So print the data to the serial port followed by the characters written. So syntax is serial dot println value. For example, serial dot print, which means data print continuously. 1, 2, 3, 4, 5, 6, 7, 8, 9, up to so on. For example, serial dot print ln in prime, which means 1, the 2 prints in second line. So like that 3, 4, 5, 6, 7, 7, 8 and so on. So we can easily identify the difference between the serial dot print and serial dot println. So again I am repeating, serial dot print means the data print continuously. Coming to the serial dot println, the data prints again new line. So first line print, take a new line. This is the second line. So two value print line means new line. Third line. Like the data print will be printed. So what is the value? The value to print any data type. Tinkercad is a free online 3D design and modeling tool that is easy to use and a small learning curve. What is the features of the Tinkercad? The first one is the user can design simple and complex objects, build electronic circuits, and create a coding blocks to control the objects. Tinkercad is also used to preview and align multiple objects along any axis, and also align the objects related to a different shape. What are the uses of the Tinkercad? Tinkercad used by kids, educators, and hobbyists. It is also a popular platform tool for creating models for 3D printing, and it is offered to use schools and as introduction to constructive solid geometry. Accessibility. Tinkercad is web-based, so it is also used anywhere in the an internet connection projects. Users can bring their Tinkercad projects into a real life using 3D printing, laser cutting, or building the blocks. Controlling of LED using Arduino. What are the components are required? First one Arduino, resistor, LED, and connecting wires. This is a circuit diagram of this experiment. Go one. So this is Tinkercad software. Actually, I'm logging. First, I'm log out, and I will show the how to log into this Tinkercad software. So Tinkercad is the Autodesk company software. So I'm clicking on login. So personal account, sign with Google. I'm logging into Tinkercad. Okay, we can see the left hand side. I'm the Gaddam Ashok, my logo, my user ID. Click on home, classes, design, collections, tutorial, and challenges. These are the designs. These are circuits done by me previously. In the Tinkercad software, we can the data is automatically saved. What are doing and left out immediately from the software. This automatically save the whatever we did in the software at the time. So I'm coming to right side. This is my logo, my account. I'm clicking on plus icon, create. So in that we can see the 3D designs, which means designing of blocks, circuits, which means electronics, and cloud box. Just I'm clicking on circuits. I'm clicking on the circuit. Okay, this is the interface of the Tinkercad software. The code start simulation send to component search. In the search, I'm searching components. What are the components? First, we need Arduino R3. I'm clicking a place here. And what we need, another one is resistor. Next, we need resistor. So another component is resistor. Just I'm clicking on resistor. I'm dragging and place here and resistor. So another component LED. The code, just minimize it. Code dot click on LED. LED. So LED I'm placing here. So I think resistor is gone. I'm again place the resistor. Just resistor. Okay. And I'm doing connections. I need two connections. Go to connection wire. So normal. So I'm selecting 9 and connect here. And another end of the resistor connected to the anode of the LED. So this is a positive way. So I'm changing the green color to red color. So green to red. So this also green to red color. And this I'm cathode to ground. So cathode to ground. So it is a black color. I'm go to black color. So we know already. So this is the digital pins and this is the analog pins. So LED is a digital components. So I'm connected, so that I'm connected to the digital pins. Okay. So next I need to write the code. For that one, just go to the click on code. In the code, blocks and text is there. Just click on the text, continue. So we can see, we can see the code. We already discussed this part. What is void setup and what is while loop. Okay, void setup means initialization purpose. It is runs only one time. So what is while loop? It is continuously runs until the power turn off. Okay, so just until the power turn off. Okay, so LED space blinking it. So which means is indirectly connected to the pin number 13. You can see the one LED in the Arduino board. So is directly connected to the pin number 13. So default is written the pin number 13 here. So that I'm changing to pin number, I'm connected to pin number 9. So I'm changing here to pin number 9. Here pin number 9. Here also 9. And here also 9. So I'm going to turn off. So here I'm changing. So pin number 9. And here also 9. And here also 9. And during the last some of the videos we are already discussed the delay timer function. So delay. So we know that in brackets of the delay, this 1000 is microseconds. ms microseconds. It is 1000 microseconds, which equals to 1 second. Which is equals to 1 second. So 1, which means the LED is connected to pin number 9. This turn on. High means 1. So 1 high equals to 5 holes. So which means it is turn on one time, turn on one time, wait 1 second, on off to off and 1 second. What happened next? It is again repeated. So while loop means it's continuously repeat until the power off. So first time is completed. So second time again the microcontroller comes to digital write 9 high, which means again LED on. Again LED on. So again on, delay 1000 microsecond, which means on at 1 second and off 1 second. Is continuously running until the power off to the microcontroller. Power off to the microcontroller. Okay. So just I'm executing. This coming to here. Start simulation. I'm clicking here start simulation. So it is initializing. So you can see on, off. First off, on, next off, on, off, on. It is continuously repeating. It's continuously repeating. So I'm stop simulation. So it is turn off. Again I'm checking this working or not. Just click on start simulation. So it is continuously on and off, on and on and off, on and off. Okay. Blinking of LED is completed. So next we will see the connect the two LEDs alternate blinking at times, blinking at same times and blinking off at sometimes. Okay. For that one we need another LED, another another LED. Click on that. So I'm clicking here. So two LEDs. So I need two resistors. So resistor I'm dragging here. So I'm connected to this LED pin number 8. Pin number 8 is connecting. So I'm clicking here. I'm clicking into anode and this cathode and this cathode. No, I'll connect it here. I'll connect it to here. I'll again connect it to here. So I'm clicking the LED cathode and just dragging. I'm clicking to drag. Okay, this is black color. Done. So it is not good, looking not good. So I'm collect the line. Just I'm go to connect the another LED. Done. So Pin number 8, pin number stop simulation, sorry. So pin number 8 and pin number 9 is connected. Go to the code. So again, so this is the setup, wide setup for the one pin. So I'm selecting two pin. So I'm just clicking here, copy and paste the code on pin number 8. So this is the one code. So I'm just copy this code. I'm copying this code. Just enter the code. Pin number 8 should be off. So I'm writing pin number 8 here. Caps on low. So 1 second is on. Again it is I'm writing. So I'm just enter. I'm select the pin number 9 again. Copy and paste here. So pin number, so first example, pin number 8 high and pin number 9 low. Next I'm writing pin number 8 here and pin number 9. Pin number 8 is pin number 9, perfect. We'll see the initialization, how it is works. Just smart simulation. It is initialization. So on, perfect. One LED is on, one LED is off, one LED is on, one LED is off. So we need to write again stop simulation. After this we need to write the code for on the LEDs same time, on off the LEDs, two LEDs at same time. So for that, just I'm writing to take him these three lines, copy here and paste here. So we need to two LEDs off. So pin number 9 also off, which means low. Okay, 1 second is off. So next I'm copy this code same as this, just copying and paste the code. So pin number 9. So I'm taking high copy, paste here and paste here. Okay, so high. So one LED is on, one LED is off. Next another LED is on, LED off. Next two LEDs off. Again two LEDs on. We'll see. Just click on start simulation. Yeah, one LED is on, one LED is off, two LEDs off, two LEDs on. Perfect. Okay. So just smart simulation. So two LEDs is completed. I'm add another LED to this. Just clicking this. So I want to add the another LED. So I'm going to drag to another LED here and also drag the LED to here. Okay. So I'm just connecting the LEDs pin number 7 and this go to pin number 7. So this is more color. This are black color is already there. So I'm change the color. So I'm going to change the colors. So orange. This is also orange. I'm changing the color to orange. Okay, fine. So this cathode is connected to again ground. Perfect. So here it is come. I'm going to the code. Just I'm going to the code. Pin number 8 and pin number 9 has coded done. So pin number 7 need to define the pin. While in the wire setup we need to define the pin number 7. Okay. Just click and enter. Just paste the code. So just I'm arranging the code in the proper manner. So pin number 7. Okay, pin number 7 is also perfect. Pin number 7, pin number 8, pin number 9, perfect. Next, so we need to add here. So what we need to add? Pin number 7. Pin number 7 should be low, which means off. So pin number 9 I'm replacing with pin number 7. So next, one LED is off. Next, just I'm clicking here and paste the same code, replacing 9 in place of 9 I'm replacing with 7. So perfect. So which means 9 pin is I. So in this case, just go and enter the code and just copy the 3 lines 4 lines from up to seconds. Copy the code and paste the code. So we need to, so up to here 9, first 8 number pin LED is on, remaining 2 LED is off. In this code 9 number LED is on, remaining 2 codes are off. So coming to this we need to on the 7 number LED. So 7 number LED is where is here. So we need to write high and remaining 2 must be low. I'm just click on low. Okay. Pin number 7, pin number 8 is done. Okay, next 3 LEDs are off. Just I'm clicking there, digital write, copy and paste. So pin number 7 must be off. Okay, pin number 7 is off. Next, so again 3 LEDs are on. So pin number 8 and pin number LEDs are already on. We need to write the code for pin number 7. Just I'm right here, pin number 7 and pin number 7. So we know we know that this is the pin setup, wide setup. So in this case, in this loop from year to year, wide setup, which means we are initialize the pins. For example, pin number 7 as the output, pin number 8 as the output, and pin number 9 as the output. Perfect. Wide setup is completed. Next, coming to while loop from here to here, pin number from line number 11 to from line number 34 is a while loop. What is the meaning of while loop? It is a continuously running the function until the power off. So that first 3 lines execute, next delay 1 line execute, which means on the 8 number LED as a 1 minute, 1 second. Then again this 3 lines execute, again 1 second is wait, which means here coming to 8 number is LED off, 9 number is on as a 1 second. Coming to these lines, what happened? LED in 8 and 9 is off, and 7 number LED is on as a 1 second with help of delay function. So coming to these lines, what happened? 8, 9, 7 number LEDs are off with a 1 second. With help of delay function. So coming to 8, 9, 7. These LEDs on with help of 1 second. Okay. So we'll execute the program. So we'll execute start simulation, initializing. So done, initializing done. First number LED is on, next is on, 2 are off, next 3 are on, next 1 it is on. So after 3, so we need to do what to do? Again 3 is on, so again we need to 3 off. So for that, click on smart simulation, just enter. So where is the 3 LEDs are off? This. So just copy this code from here to microseconds. So I'm pasting the code here. Okay. So I'm with start simulation. I will check the code. So 1, 7 is on, totally off, totally on, and totally off. Next 8 number is LED. So perfect. We're done with really. We'll do the traffic light experiments. Okay. For that, I'm writing something code here. So first, I'm taking the LEDs which are connected to 8, 9, 10. So for example, int red LED, I'm sure the value in as the 8. Here I'm store the 8, which means red LED equals to 8. So red LED equals to 8. Next yellow LED is 9 and green LED it is 10. Okay, I'm taking 3 LEDs, but the connections are different. So we'll do the connections first. Okay, for that one I'm relating this one. So this connection, this connection and this connection. Okay, first we will see the code. Pin number 8 red, pin number 8 red. So I'm connected to here. So pin number 9 and the pin number 10. Okay, so we'll see the code pin number 9, pin number 10 and pin number 11. So next I'm initialize the pins. Here in the wire setup and initialize the pins. Pin mode red LED output. Red LED means 8. Pin mode yellow LED output. Yellow LED means 9. So which means I'm indirectly write the pin mode 8 LED output and pin mode 9 LED output. Pin mode 10 LED output. Fine. Next, this is a while loop. So in the while loop, I'm directly first turn off, ready, go, and warning. So I'm writing like that. First, what will happen? I will explain. So digital write red LED high, which means pin number 8. Pin number 8 LED high. So digital write yellow LED low, digital write green LED low, and delay 5 seconds, which means 5000 microseconds means 5000 microseconds equals to 5 seconds. Okay, 5 seconds delay I'm right here. Next I'm at the yellow LED, which means first red, next yellow, ready. So for that, red is off, yellow is on, and green is off for the 2 seconds. Next, what will happen? Next, green go, which means green LED. Pin number green LED means pin number 10 LED. Pin number 10 LED on. Remaining two LEDs, red and green yellow LEDs are off. Red and yellow LEDs are off. Okay, green LED on for the 5 seconds. Next, after the green LED, what will happen? We go to the yellow LED for warning before stopping. Warning before stopping. So for that green LED, so green LED off. Next red LED also off. Next what will happen? Yellow LED on for the 2 seconds. This cycle will be continuously repeating until the power off to the microcontroller. So I'm doing the connections also. So we will go to the smart simulation. Start the simulation. Initializing next. So it is on 5 seconds. 3, 4, 5. Next yellow 2 seconds. Next 5 seconds. 1, 2, 3, 4, 5, 6 and 1, 2. So start simulation. So we'll count the how many seconds to complete this process. So first here 5 seconds. So first here in this loop from here to here 5 seconds. From here to here 2 seconds. From here to here 5 seconds. And here to here 2 seconds. Totally 10 plus 4 14 seconds to complete the while loop once. Okay, we'll check the video. We'll check the video. Okay, click on smart simulation. Okay, so 1 2 here we can see. Here we can see the seconds of how many seconds are done. 2, 11, 12, 13 and 14. So perfect. It is matching. So controlling of LED using switch. Required components. First one is Arduino, push button, LED, resistor, connecting wires and breadboard. Controlling of LED using the push buttons. For that we already discussed what are the components are required. So we need Arduino board already taken. So breadboard. I'm taking the breadboard. Just I'm adjusting the. Just I'm go back. Just I'm adjusting. Okay, this one is not going. Okay. So next I need LED. So I'm clicking on. So resistor I'm drawing and wrap here and LED. LED is connecting. So next connecting wires. For that I'm connecting here. So first button to pin number 9. Okay. Next disconnected to. Next is already connected. So again we connected to cathode of the LED to the ground. So cathode of the LED to the ground. Perfect. For this the ground, I'm change the color. Go to the black color. This I'm changing to red color. So I'm changing into red color. Perfect. So next I need push button. Drag and drop. I'm select here. So push button. Perfect. So for this resistor, I'm changing ohms. 220 ohms. So it's a kilo ohms. I'm changing into ohms. Okay. So I'm taking the push button already. So I'm connecting the push button. So one end is connected to pin number 7 and this end is connected to the V in or 5 volts. I'm going like this, like this, like this. Sorry, I'm selecting from here, 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 and 5 volts. Okay. So again I connected. So I'm taking another resistor. So I'm placing here another resistor. So I'm from here to I'm connect the resistor. So I'm resistor to like this way we'll go here and connect it to the ground. Okay, I'm changing the two colors are same, so I'm changing this color to another color. So I'm select go to the colors. So I'm green. So this one also is green. This is also green. Okay. So connections are done. We go for the screen code. So coming to the code, I'm select the so coming to the push button 7 is connected to pin number 7, which means 7 number is stored in push button. So next LED equals to 9, which means LED 9 number is stored in LED pin. So next, so int button status equals to 0. Next white setup, we know that white setup means only initializing the pins and pin types. Next, this is a while loop. So in that while loop from pin line number 12 to line number 22, the while loop. So first I'm read the button. So button means button state first equals to 0. So button state equals 0 and button is equals to digital read button pin means 7. So digital read button number 7, we read the from data from button 7 digital pin number 7 and stored in digital read. So digital read equals to button 7. So this data will stored in button status. First button status equals to 0. If you are press the push button, the button status equals to 1. Okay, push button equals to 1. So if push button equals to 1, which means push button state which we know not already button state equals to 1 equal to high. High means high equals to we know that 1. So we are comparing the two values, which means button state and high. So equal to means manam we are comparing. So we are comparing button status and high with help of equal to. So 1 equal to 1, which means the condition is true. So this condition is true. So this line will be executed. Else, if the condition is false, what will happen? This line will be executed. So, okay. So it is done. So I'm clicking on start simulation. So you press the LED. So it is something went wrong. We'll do some changes. Go to smart simulation, stop simulation. So this LED is connected to here. Okay. So this line is connected here. Start simulation, on, off. So we need to change the code. First we'll change the code. Go to the code. So it is I. Click on high. We try to write the high. Smart. Start simulation. So click on the push button. It is on. Click on the push button. The LED is on. So if it is unpressed, it is off. Click on the push button. It is on. So like that. We'll do some changes in the code again. So if we in this experiment we did if the push button is pressed, the LED is on. We'll do reverse. If the push button is pressed, the LED off. So for that one, come to the code and change here. So in place of white, write the low. Okay. Next, smart. Next, start the simulation. Initializing. So it is on. So as per our requirement, it is on. So we need to press the LED. Then the LED. Then we need to press the push button, the LED off. So it is off. So our requirement is match. So see that video, see that if the push button is pressed, the LED is off. If unpressed, the LED is on. Okay. Next we need to connect the another push button, sorry, another LED. So for that one, just I'm coming to here and copy this code and press here. So it is connected to pin number 10. So if the what is experiment is one LED is blinking, another is off. one LED is on, another LED is off. If the press the button, the LED, which LED is on, the LED should be off. What is the LED off? That should be on. So for that we need to write this code. So I'm going to push button high, click on high. So coming to here, so LED pin 2, LED pin 2, LED pin 1. So this is LED pin 1 and this is LED pin 2. So coming to LED pin 1 and copy this and paste LED pin number 2. Okay, push button, digital read push button. If the push button equals to I, so LED pin number 1 I. So and LED pin number should be off. For that one, so just copy here and enter the code LED number 2 off. So come to here, so LED 1, come to here, just copy this code and paste here. So LED 1 low, LED 1 low and LED 2 high. Okay, so I'm doing the LED 1 low and LED 2 low. So when it explain, so this is the I'm defining pins. LED pin equals to 7. Sorry, push button pin equals to 7. LED pin equals to 9, and LED pin number 2 equals to 10. So in button state equals 0, and this is a while loop. While loop means we are initializing the pins and what is the function of the pins. So pin mode. So pin button means 7 here and pull up, and pin mode LED pin and output. LED pin number 1 means 9. So here 9 and output, which means the LED pin number acts as a output. And coming to LED pin number 2. So what is LED pin number 2? 10. So LED pin number 10. So it is acts as a output. So coming to the while loop from line number 14 to 26. So while loop, first we are read the value from the digital read push button. Push button pin means 7. So we read the digital read from the button 7, that value stored in the button state. So initially the button state is 0. So then button state equals to 0. Next we read from the value from the digital pin number 7. So it is after reading the value is button state equals to 1, which means I. So if button state equals to I, so we need to by LED 1 on and LED 2 off. In case this condition is false, so this condition is executed. What is the condition? Digital write LED 1 low and digital write LED 2 high, which means pin number 7 LED, so pin number 9 LED low and pin number 10 LED high. So this code is completed. We'll go to the connections part. So I'm connected one part. So we need another LED. Sorry, we need another LED. Just click here. Go to LED. I'm placing here LED and resistor, and just I'm placing the resistor here. So connect this pin number to 10. Pin number 10, and this is connected to ground. Okay, so these perfect connections are perfect. I'm start simulation. Click on start simulation. So one LED 2 is on, LED 1 is off. If I press this, LED 1 is on, LED 2 is off. If I unpressed, LED 2 is pressed, LED 2 is on, and LED 1 is off. Checking it is working or not. So first click on start simulation. So pin LED 2 is on. If I click on push button, the LED 1 is on and LED 2 is off. If it is unpressed, LED 2 is on and LED 1 is off. We'll go to the code. According to the code, if the press equals to I, LED is on, and according to this one, it is low. So this if it is low, I'm clicking just smart simulation. stop simulation. This is low, low, low. Okay, I'm checking it's working or not. Just click on start simulation initialization. So LED1 is on. So LED1 is on. So if I click, LED2 is on. If I click, LED2 is on. If I unpress the push button, so LED1 is on and LED2 is off. LED1 is on and LED2 is off. Okay, so stop. So again I'm changing the code. So if it is I, so click on start simulation. If it is I, so it is 1. 1 means, so we need to LED1 I and LED2 is off. Checking the condition. So checking the condition, according to check the condition. So according to the condition, it is perfect. So if I press digital button state equal I, which means 1 equals to button state. So LED1 is I, it is false, LED2 is I, so it is perfect.